Following on from the previous video, we got to this stage here where we can express where if we work in terms of theta, we can express this area as this. So if we work in terms of theta, well, let y equals a sine theta. Well, if y equals a sine theta, then dy equals this thing here. If dy equals this thing here, we can put it into this dy here. So this whole thing here becomes this. Okay, so now tidy this up. This will then become this. Now it's just a matter of integrating this. We know how to integrate cos squared of theta. We've done this in the past. Remember cos squared of theta. Well, cos squared of theta equals this block here. And remember, we've seen this whole thing in the past. So we can put this into this block here. So this whole thing here becomes this. Okay, so now this thing here is easy to integrate. So integrate this, it will then give you this. Okay, and then remember that whenever you have sine x times cos of x, you can jump to this. Well, here you've got this. Well, here you've got this. So you can actually put this back into here. Okay, so this 4 will later become a 2 because well if you put this back into here, it will then become this. Okay, so once you're here, you can actually jump back into here because normally yeah, well, once you're here, you can actually jump back into here because let's say you're trying to integrate this thing here. You're trying to integrate this. Well, integrate this, it will then give you this. Well, by right, we should do this. Put b into here, and then put b into here. So that will become a squared, and then we put b into here. So that will be b squared, and then put it into here plus b. And then take away, put 0 into here, so that would be 0 squared plus 0. Put 0 into here, then that would be 0 here. So by right, it should be like this. But if you jump into here, you all actually jump back into here. So this then becomes a squared x squared plus a squared x. B0 here. Well, this would be the same thing. It would be a squared b squared, and then put b into here, so that will be plus a squared b, and then take away 0, well, blah blah. You all actually jump back into here. So when you are here, when you are here, you can jump back into here. Okay, so from here, that will then take us to here. Okay, so hang on. So now we need to so we are currently here at the moment. Now we need to convert theta. We now need to convert theta. Okay, so y being remember we said that y equals a sine theta. Well, divide both sides by a. That will then give you this, and then inverse sine equally to both sides. That will then give you this. So theta equals this thing here. So remember, as we're summing up all these slices, y is moving about. So no matter where y is, we can always work out theta. No matter where y is, let's say the height here is currently here. Well, if the height is y, then you can get y divided by the hypotenuse here, which is a, and then if you want to know the angle, then you arc sine to both sides. So well, anyway, theta equals this thing here. Okay, so now well, earlier we were at this stage here where area equals this thing here. So hang on, let me go back one step. Hang on, let me go back one step. So earlier we were here. We can jump back into here. Okay, that would then lead us to this. So we are currently at this stage here. Okay, so hang on. So we are currently at this stage here. So we've just jumped back into here. The a squared just jumped back into here. But don't forget, when the a squared jumps back into here, by right we should have this a squared sine theta cos theta. But when the a squared jumps back into here, it should give us this. But rewrite this as a sine theta, a cos theta. So basically break up this a squared here. That will then give you this. Because later on this thing here becomes y, and this thing here becomes the x direction. Well, just write as this for the time being. Now remember, theta equals this thing here. So we can put this into the theta here. Okay, so put this into here. That will then give you this a squared, and then don't forget theta is this bit here, because we need to convert theta back, because if you think about it, we are summing up everything and we are moving in the y direction. We are moving in the y direction. Theta has nothing to do with us moving in the y direction, so we need to convert theta. Okay, so theta this theta here becomes this thing here, and this thing here. If you look at the diagram, a sine theta is really the height here. A sine theta is really the height. So this here is really y, and a cos theta is really in the x direction. It's really the x direction as we're moving along. It is x. But remember, we are summing up everything. We are summing up everything in terms of dy. We are moving in the y direction. We don't want it in terms of theta, and we don't want it in terms of x, because we are moving in the y direction. So we need to express everything in terms of y. So this thing here, we cannot. We need to convert this. We are not working in terms of theta. So put this back into here. That would then become this, and then this bit here is really the height, which is y. This thing here is really the x. But we don't want it in terms of x, because we are moving in the y direction. We are moving in the y direction. We don't want it in terms of x. So hang on. So remember that the area of a circle is given by this. But then if you rearrange this, x is given by this thing here, x. So when you rearrange this equation for the circle, in terms of x, in the x direction, the x length is given by this. Badly explained, forgive me on this. So this thing here is y. This thing here is x, but we don't want it in terms of x. We are summing up everything in terms of, we are moving in the y direction. So no matter where y is, we need to express the x length in terms of y. Well, the way we do that is by rearranging this equation here. So this thing here becomes this. Okay, so overall the area is given by this. So now we can put b back into here. So now we can put b into here. Put b into here and put b into here. So this whole thing here becomes this. Okay, and by the way, this I'll continue in the next video. Okay, so overall the answer is given by this.